right, so going through a similar question here, the cost function is given as follows, and the first question is what is the cost at the production level of 1250? So what you're going to do is you're just going to take the 1250 and plug it into the original cost function. So again, we'll just have C of 1250 is equal to 16 square root 1250 and then plus the 1250 squared over 1,000. And that will give us this 2,128.185. I will notice here that at the very bottom of this page, it says to give answers in 3 decimal places. So this might feel kind of weird to you. We're talking about cost, you're thinking about dollars and cents, but they do say to 3 decimal places. So that's the reason why I'm not rounding this 5 up or using the 5 to round up to 9. I'm going to keep it at 3 decimal places. Now, the next part is what is the average cost? Remember, average cost is the cost divided by X. Now, here, there's 2 things that I want to notice. At the end of the problem, they are going to ask us to minimize this average cost function. So I think it's helpful to simplify here before going any further. So what I did is I took my cost function, the 16 square root X, and I rewrote that square root as x to the 1/2. And that is simply because when I divide by x here, I will subtract those exponents. So I'll take 1/2 minus 1, and that will give us 16 over x to the 1/2 power. Again, the bigger exponent is where I end. Then for the second term, I have x squared over 1,000. Notice that when I'm talking about the average cost, this is just a quick for your information, but your cost function term is x squared over 1,000. You then divide that by x, and then x is over 1. So if you do your keep, change, flip, that x over 1 will become 1 over x. So to kind of prevent going through all of that, what you can think about is that if you do have a fraction for your average cost function, you're just going to stick that x that you're dividing by also in the denominator. So you would, if you did like the, this is the fraction divided by x, you would see that it would come out that way anyway. And then from that fraction expression, I have x squared divided by x, so that just gives us an x in the numerator. So simplifying average cost would be x over 1,000. Now from here, what I would then do is I would plug in, because they are asking about a production level of 1250, I would plug into that average cost function my 1250. So I would have 16 over 1250 raised to the 1/2 power, and then plus the 1250 over 1,000. Now, one word of caution here, if you do this on your calculator, just remember you're taking 16 divided by, and then the 1250 is raised to the 1/2 power. And you would want to put the 1250 raised to the 1/2 power, all of that in parentheses, to make sure that they don't just raise it to the first and divide by 2. You want that whole power as 1/2. Another way you could do this, so you would get that number and then add it to the 1250 over 1,000. So that's one way that you could approach it. The other way is you could potentially put both of these together. That would be fine. You don't have to write it in 2 steps. Or you could write it as 16 over the square root of 1250, because we know that that 1/2 power is the same thing as a square root. So either way, again, the calculator or the calculation there is a little more intense than the other problems that we've done, but either way, you will get 1.7025. Now they want us to round it to the third decimal, so that 25 will round us up to a 3. So again, the 7.025, the 5 will round us to a 3. So that is our average cost at the production level of 1250. Now, for the next one, we are looking at marginal cost. So for marginal cost, what we're going to do is we are going to take the derivative of the cost function. Now, of course, there it's helpful to rewrite the cost function as 16x to the 1/2, and then plus this x squared over 1,000. So bringing down the 1/2, we're going to have 16 times 1/2 x to the negative 1/2, and then plus the 2x will come down, and then the 1,000 in the denominator will just carry along. Again, the 1,000 is a constant coefficient, so that is just going to carry along. So that's going to give us 16 divided by 2 will give us 8x to the negative 1/2, and then plus x over 500. Now, that's not our final answer because we then have to plug in our 1250 into this marginal cost function. So we would then plug in the 1250 raised to the negative 1/2 plus the 1250 over 500. Now again, when you're doing that on your calculator, just be really careful to put the whole exponent in the parentheses, so negative 1/2 in parentheses, and then add that to the 1250 over the 500. And that gives you 2.726, and you will just keep it at 26 because of the 2 afterwards. So that's going to be rounded to 2 decimal places, 2.726.